I'm NASA astronaut Jessica Meir, currently living on board the International Space Station. In our daily lives, we use electricity in many forms, from the lights in our homes to the components powering our phones. In nearly all of these instances, electrical energy is transmitted through wires. But did you know that light itself carries energy? When you turn on a flashlight, an electromagnetic wave is generated that travels through the air, carrying energy proportional to the frequency of the light. Now, depending on the wavelength, light can act in many different ways with varying uses. You have visible light to see, radio waves to transmit information, microwaves to heat food, or X-rays to see your bones. While each of these frequencies behaves differently, they all carry energy. So you might naturally ask, instead of relying on wires, could there be a way to transmit energy with electromagnetic waves? Today I'm going to show you a device that you can inexpensively build at home that will allow you to use electromagnetic waves to wirelessly power an LED. Here I have a device called the LEctenna, which stands for LED Rectifying Antenna. It's made up of an LED paired with a component called the Schottky diode. These are both diodes, electrical components that only allow current flow in one direction. Here, we've oriented them to allow current to flow in a loop through the two diodes. On board the ISS, we have Wi-Fi, just like you might have at home. Wi-Fi uses electromagnetic waves in the microwave frequency range. Now, if we put the LEctenna nearby the Wi-Fi source, it lights up. Because of how antennas work, the power density of the signal drops off as we get further away from the antenna. So you can see, as we move the device away, it gets dimmer and dimmer until it goes out. With this LEctenna, there isn't any internal power supply. The only energy it uses is the energy being sent to it. So you may ask, why does this happen? Waves have peaks and troughs. These peaks and troughs correspond to how the wave distributes electrical charge in the LEctenna. This charge imbalance then causes current to flow through the device, causing the LED to light up. If you're interested in a more technical explanation, we have a link to a webpage with our collaborators at the Naval Research Laboratory that explains it in more depth. If you get the components, you can easily build your own LEctenna and try it at home. Simply place the LEctenna near your phone's antenna or a Wi-Fi router while using the internet. Depending on your phone, you may need to experiment to find where the antenna is inside it. While this is a cool device on its own, our collaborators have begun investigating the wide range of possible applications for this technology in the real world. We could find ways to wirelessly charge our mobile devices or remotely power drones. But one of the most interesting applications that they're looking into is space-based solar panel arrays. Using this wireless power technology, we may someday be able to harvest solar energy in space and beam it down for use on Earth. This way, we'd be able to circumvent the challenges of the day, night cycle, and weather, and take advantage of sunlight in space where it's brighter than anywhere on Earth. This technology could be an incredible option in the future for providing clean energy to power the world. If you're interested in making your own LEctenna device for fun, or as a class experiment, follow the link in the description to see where we can get the parts and a quick demonstration on how to easily build one at home. Thanks for watching!